I welcome you all. Today I'm going to start with Embedded C. In Embedded C, I'll start with an important topic, that is data type supported by 8051 microcontroller. 8051 microcontroller ALU is non-fractional. 8051 cannot process fractional numbers, so it does not support fractional data also. So its data types are all non-fractional. It supports five types of data. Based on size, it can be categorized into three: character, integer, bit, and based on sign, it can be categorized into two: unsigned and signed. So, unsigned character, it is an 8-bit data whose value will always be positive. Therefore, it ranges from 0 to 255. Signed character, it is 8-bit data whose value can be positive or negative, so its range is -128 to +127. So if my data is in this range 0 to 255, I will declare variable as unsigned character. If my data value is positive or negative as well, so I will declare variable as signed character. If my data requirement is higher than the 255, then there is another option, integer. So unsigned integer means 2-byte value which will be always positive. Hence it ranges from 0 to 65,535. And signed integer range from -32,768 to +32,767. So based on your data range, you have to select one out of these four data types. Suppose my value is ranging from -10,000 to +20,000. So I will select signed integer. I will declare my variable as signed integer. If value is always positive ranging from 0 to 100, I will select unsigned character. If for value ranging from 0 to 100 somebody declare variable as unsigned integer, so logically it is correct, but it is inefficient programming. You are consuming 2-byte work which could be completed using 1 byte. So you are losing 1 byte of precious RAM size. The RAM size is very small. For example, in 8051 it is 128. So every byte is important. So selection of data type is important. Then the fifth one is bit type data. If you are working on bit logic 0, logic 1, so you declare your variable as bit. In 8051, internal RAM memory has in bit addressable section of RAM. Part of RAM memory is bit addressable. Its address is ranging from 20H to 2FH. These 16 RAM locations are bit addressable. These 16 RAM locations are bit addressable, which means total 128 bits are bit addressable. And these bits range from 00H to 7FH. So address of bit type variable in the RAM memory is ranging from 00H to 7FH. Okay, so these are the five data types. There are two keywords also which also play important role. The first one is S bit. There are some SFRs which are bit addressable. For example, all ports are bit addressable. You want to access bit of that SFR, so how we can do that? So in C language, we do not access bits with their addresses. Instead, we define identifier, and that definition is done with the help of S bit. So I explained with the example. So you can see here, I have used S bit above main function. So here I am defining my bit as bit 0 of port 0. So wherever in my program I am using my bit, I am addressing bit 0 of port 0. In C language, this is the way we can access a bit. There is no other provision. You cannot use bit 0 dot 0 directly in your program. You have to define it using S bit, and that identifier is used in place of address of a bit. So here I have done two definition. One is my bit, bit 0 of port 0. Second is S bit, your bit, bit 0 of port 1. And within the main function, variable declaration is done. So this is variable which is created inside RAM memory. So this is flag is a bit. So this bit is a variable which is created inside a RAM location. And these are SFRs. So this is the difference. SFRs are defined before the main function. However, variables are declared inside the main function. So flag is set, my bit is reset, flag is transferred to my bit, bit 0, port 0, your bit is reset. Let us execute this. So flag is set, my bit is reset, then my bit is set, your bit is reset, and this is the end of the program. So this is how S bit and bit works. Similarly, SFR, with one example I explain you the use of SFR. This is my main program in which I have included a header file register51.h, and in this register file I have defined all SFRs. All SFRs are defined within this file. You can see here P0 is defined as SFR whose address is 80H. So in program wherever I am using P0 I am addressing 80H. So this is a file in which all SFRs are defined. All bits of SFRs are also defined. For example, you can see here TCON register, S bit TF08DH. So TF0 is representing a bit whose address is 8DH. So in program I am not going to use 8DH. In program I am going to use TF0. It is addressing 8DH. So you can see in this program I have used identifier P0, P1, P2, P3. You can change this name. You can change these identifiers. If you want to change, you have to make changes here. You can use another words also like this. Port 0 also you can do it. So it is up to you. Identifier, you can choose your identifier name. So that was all about data types. Next is arithmetic operators. C supports four operations: addition, subtraction, multiplication, division. As I already explained, 8051 does not support fractional operation. So in case of division, we do not get 2. If I divide 5 by 2, I will not get 2.5. If I divide 5 by 2, I will get 2 as quotient and 1 as remainder. So this backslash operator gives me quotient, and this percent sign, this is also called as mod operator, gives me remainder. So 5 divided by 2 gives me 2 as quotient. 5 divided by 2 gives me 1 as remainder. In Turbo C, we use 5 divided by 2, we will get 2.5 as the result because Turbo C CPU Turbo C operates on 8086 series of microprocessor, and these microprocessor consists of fractional unit also. That is why you get fractional number as a result also. So in case of addition, two variables are declared, a and b. A is 5, b is 6. C is the result, a plus b is 11. So C will be 11. Then 10 minus 6 will be 4. 5 into 6 is 30. Okay. So let us go through one program also. So in this program, I have declared a and b as two variables, unsigned character variables. So I will make their values always positive. So a is 2, b is 5. Port 0 is a plus b. 5 plus 2 will be 7. 5 minus 2 will be 3. 5 into 2 will be 10. 5 divided by 2 quotient will be 2. 5 divided by 1 quotient will be 1. Remainder will be 1. So let us execute this program. Okay. So a is 2, b is 5. Now 5 plus 2 is 7. So you can see here port 0 is 7. Then port 1 is 3. Then port 2 is 10. 10 in hexadecimal is 0A. Then 2 and 1. So that is arithmetic operators.